Sir, please start. Well, sir.
A very,
Okay.
a very good afternoon to all participants, especially our respected resource person. Just for introduction of our speaker to the audience, to our speakers, to our participants. Dr. Abhijit Ghosh is a young and energetic scientist who is currently working in ICAR, Indian Grassland and Fodder Research Institute, Jhansi. Oh, sorry, there was some network issue. Dr. Abhijit Ghosh, as I mentioned, that he is working as a scientist in Grassland and Silvopasture Management Division of IGFRI. Dr. Ghosh has published more than 60 international research papers that have been published in high impact journals, and he has, to his credit, a number of book chapters, popular articles, books. He has developed the concept of soil functionality in eco-restored lands. He has recently been awarded with Young Scientist Award by Indian Science Congress, Japan. Japan International Award for Young Agricultural Researchers by Japan government very recently. And also he has received DST Young Scientist and Technologist Research Grant. And just a few weeks back, he also received NASF project on grassland restoration in the Himalayan region and in the semi-arid grasslands of our country. Dr. Abhijit, I, on behalf of Organizing Committee, NADCL, and IGFRI Regional Research Station, Srinagar, heartily welcome you for your talk on quantifying carbon dynamics in silvipastoral systems, implications for enhancing restoration efficiency. I hope this talk is going to be a very enlightening one, especially in the wake of climate change the world is grappling with. So there is a need of studying or quantifying carbon dynamics in agroforestry systems so that farmers may earn what we call as payment for ecosystem services like carbon credits and all that. So this lecture is further will diversify the research aptitude and research diaspora. This will be of great significance to all our participants in their respective areas. Dr. Abhijit, for your information, our participants are from diverse background, although majority of them are from agroforestry background, but we have a good number of participants from other streams like veterinary sciences, horticulture, soil science, agronomy, and most of them are from state agriculture universities, although very good number is from state agriculture universities and KVKs. So your PPT is visible. You are audible as well. So please proceed. The floor is all yours, sir.
Thank you, sir. Thank you very much, sir. I sincerely acknowledge the organizing committee and I thank them for inviting me in this forum. Today, I will specifically talk on quantifying carbon dynamics in silvopastoral systems for enhancing restoration efficiency. I will be more focused on quantification part of carbon dynamics in a silvopastoral system and how they are related to the eco restoration or ecological restoration. Uh, Briefly, uh, carbon cycle is in any biological system or crop or land use system, agricultural or biological land use system. It is divided in five pools. They are atmospheric pool, geologic pool, oceanic pool, petrologic pool, and biotic pool. Now, for silvopastoral system, the most three important pools are the atmospheric pool, biotic pool, and petrologic pool. in atmospheric pool, we have nearly 780 petagram of carbon, and in petrogenic pool, we have nearly more than 1500 petagram of carbon. And in biotic pool, we have nearly 500 to 650 petagram of carbon. How they are related to the silvopastoral system carbon, how they are related to biotic, abiotic, and the soil carbon pool, that is ecosystem carbon pool. In general, ecosystem, the four pool, that is biotic carbon, soil carbon, and abiotic carbon, as well as the aquatic carbon, are interrelated and named as ecosystem carbon. Sometimes the aquatic carbon are also mentioned as blue carbon. Now we can see that in biotic carbon pool, there are three parts, that is above ground, below ground, and biofuel. And in soil organic carbon, we have active fraction, immediate fraction, and passive fraction. They are mostly popularly known as labile carbon and recalcitrant soil organic carbon. And in abiotic soil carbon pool or abiotic carbon pool, there are two types of carbon. One is natural, another one is pedogenic, anthropogenic. In naturals, there is soil inorganic carbon, that is carbonate carbon, that is and in anthropogenic case, we have deep injection, that is deep layer carbon, that may be peat or stratified inorganic carbon, and dissolved materials that are adsorbed on the soil particles and other living materials, and they are interconnected and forming the ecosystem carbon pools. And how the carbon flows in a silvopastoral system, you can see there are four basic processes, that is uptake or fixation, transfer, maybe through respiration, oxidation, and methanogenesis process, whereas transfer of ecosystem carbon occurs through soil erosion and biomass harvest. That is tree harvest in tree biomass or grass biomass, and through leaching, it is accumulated in the aquatic pool or in the deep layer, that is dissolved organic. Uptake or fixation occur through photosynthesis and deposition process. And that is the process of carbon input in biomass also. Now, in a nutshell, in a silvopastoral system, we have two basic components, that is silvi and pasture, that is tree and pasture. So we have so in the silvopastoral system, through photosynthesis, carbon is entered in the plant biomass, and it is plant biomass are deposited in the soil through two pathways. One is leaf decomposition, the deposition of leaf litter. Another is the decaying of root. And the decomposition of the leaf litter increases the soil in the soil, and this organic carbon is goes through the microbial respiration, and carbon dioxide is released in the soil solution, and this carbon dioxide eventually reacts with water in the soil to form carbonic acid, and the carbonic acid reacts potassium present in the soil, they are cation, and as a result they form calcium carbonate, magnesium carbonate, or potassium carbonate, and they are eventually fixed through as inorganic carbonate carbon in the soil. And in the same process, the root also contribute to organic and inorganic carbon fixation in the soil. However, in the meanwhile, in the process, only not photosynthesis is not happening, the respiration also taking place, and microbial respiration as well as plant respiration releases carbon dioxide in the atmosphere. In that way, also carbon is lost from the system, and it is accumulated in the atmospheric pool. So this is a dynamic ecosystem where our motive, our objective directed towards improving the carbon in the soil and the long-lived parts of the plant, like trunk, so that the carbon in the atmospheric pool is minimized and the long-lived pool is maximized to attain the maximum carbon sequestration in a silvopastoral system. So, for quantifying carbon dynamics in silvopastoral system, we need to quantify tree carbon stock as well as soil or soil carbon stock. And tree carbon, among the tree carbon stock, we need to also quantify below ground carbon stock. So there are different trees and they have different different mechanism of fixation as well as different process for estimation of carbon dynamics. So in a base for a large sample, large area, the most cumbersome job is to select a appropriate sampling area for estimation of carbon stock or carbon sequestration in silvopastoral system. For this, a nested sampling approach is followed basically. For example, we have 20 into 100 meters square, that is 2000 meters square plot. We will make nested plots of 5 into 40, that is 200 meters square, that is 1/10th of the actual area for calculation of or estimation of the represented soil organic carbon stock from silvopastoral system, that is tree carbon stock from silvopastoral system representative. Now, which part and how to collect of a tree? Tree has several parts, and how to collect and which part has to collect. For example, we have living trees with if the stem diameter is 30 centimeter, then we'll go for a non-destructive measurement and apply allometric equation for measurement of the tree biomass and carbon stock. If the tree diameter is less than more than 5 by less than 30 centimeter, then also we'll follow the same process. For understory vegetation, that is pastoral grasses first or any other crops if available, we'll go for destructive method. And for litter also we will use destructive method, that may be fine, coarse litter, fine litter or surface roots. For charcoal, ash, everything will go for destructive methods. But for dead but standing trees, we'll go similarly. For dead failed trees, we will apply also non-destructive and apply cylindrical equation or allometric equation also. So in this way, we do sampling for estimation of carbon stock in tree. This is a pictorial representation of the nested plot design for sampling various carbon pools from a silvopastoral system at appropriate scales. The small area is represented as nested plot where we have to do sampling, and these are green area is demonstrate the understanding sample plot, whereas this large dark color indicates tree is greater than 30 centimeter, that is this, and these are square hexagonal dots indicate the tree diameter, trees having diameter 5 to 30 centimeter at 1.3 meter, that is breast height. Now, what are the expected number of trees in sample plots of different size? Minimum number, what are the average number per hectare, number of trees per hectare we should consider for estimation of carbon stock? For example, if we have 5 to 10 centimeter of diameter, we have to sample for 400 trees per hectare, and if it is 10 to 30 centimeters, that is 200 trees per hectare. If it is 30 to 50, we have to go for 50 trees per hectare, and if the diameter is 50 to 70, we have to sample for 10 trees, and if it is more than 70 centimeter, we can go with only 4 trees per hectare. Now, after for measurement of tree biomass, the alternate option is to measure the tree diameter and height and develop an allometric equation, and based on that we can estimate the biomass as well as tree biomass as well as the carbon stock. So what are the process to measure tree diameter? Basically, we have to measure the tree diameter at 1.3 meter, that is breast height, or the equivalent on odd shaped trees. For example, for events, a tree having no branches, 3 meter breast height. When there is branches, the uh, bisected branching, there we have to do at 1.3 meter height, but that for both the branches we have to count. And for this type of trees having irregular trunk shape, we have to do at 1.3 and 0.5 meter diameter, 0.5 meter height. And for trees like this, where systems are there, we have to go for 1.3 meter and 0.5 meter and measure the diameter. And for measuring tree height, we have to use Pythagoras theorem. And alternatively, we have Rabi altimeter, through which we can measure the tree height by accurately positioning that and seeing at the angle of 45 degrees. Now, how to develop those allometric equation? Allometric equation are measured generally depend on tree diameter, basic on the dBH parameter, that is tree diameter at breast height, and from that we measure the total biomass using the best suitable power equation or polynomial equation. And for your information, there are several allometric information that has been already developed and standardized. This is available in this documents. You can see here. Is it visible to all of you? Hello.
Yes, Dr. Abhijit.
Please continue.
Okay. So, for example, in Western Himalayas, for Pinus roxburghi or longifolia, the biomass equation is estimated already given for based on their longitude. And for Quercus incana, there are 4 biometric equation. Rhododendron, there are also equation. Approximately, there are mostly trees. Most of the trees, the biometric allometric equation for estimation of biomass has been standardized for Western Himalayas. Similarly, for Eastern Himalayas also, northeastern ranges there are also, and similarly for northern plain, southern plain, Deccan plain, for every ecoregion, eastern plain, there are available for specific trees. Whenever it is not available for a specific tree, we have to measure, take data for at least 10 to 15 trees, and then we have to develop a polynomial or power equation having highest R square value and lowest root mean square of error. That equation we have to use. Now, not only for accurately quantifying the carbon dynamics or carbon stock in a silvopastoral system, along with the living tree, we have to consider also the dead biomass. That is the that is called as necromass of a tree. For that, we have to within the nest, we have to take sampling of 5 centimeter width and a length of 0.5 meter. This diameter we have this area we have to consider for measuring, for taking out the sample, and we have to use the cylindrical equation for measuring the biomass of the necromass, and then we have to separately measure the carbon content necromass, and then we can easily estimate the carbon stock present in the necromass. So, along with the tree, then there are grasses. For that, what we have to do for estimation of carbon dynamics of grasses or carbon stock in the grasses, we use quadrate method and quadrate of meter by 1 meter or 50 centimeter by 50 centimeter are used generally. And what is done? A plot, a 1 meter, 1 meter by 1 meter quadrant is placed 6 times in a 40 by 5 meter square transact, and thus the biomass is taken, and out of the 6, from 3 quadrant samples, randomly samples are drawn, and their carbon content is measured, and from that we can estimate the biomass as well as the carbon content in the total area. This is the calculation for total diode, and we have to take average 8 samples to record the understood and later biomass for the transact replicate. This is the process how we can estimate the carbon stock in the for tree and pastures. That is, we have to first estimate the above ground biomass, and then we have to estimate the below ground biomass. Generally, from the root shoot ratio, generally the reported root shoot ratio. If the root shoot ratio is not reported for a grass or tree, we have to estimate it for a for representative 3 to 4 trees, and for grasses for 3 to 4 tussocks we have to estimate, and then from based on that we can estimate the below ground biomass. And after that, the carbon dioxide stock is calculated as biomass plus below ground biomass into carbon percent in the particular tree or grass, and multiplied by 44 by 12, and that's how we estimate the tree and grass carbon stock. But in a whole, if we wish to quantify the soil the total carbon stock in a silvopastoral system, we consider the carbon present in the soil. In soil, carbon is present, as I mentioned, in 3 parts, that is organic carbon and inorganic carbon dynamics or carbon stock study. We generally include the organic carbon only, and the inorganic carbon is not included. And among the organic carbon, 2 fractions, that is labile carbon and recalcitrant carbon. Labile carbon is this labile organic matter, and the recalcitrant carbon is basically fulvic acid, humic. They are considered as also recalcitrant carbon or long-lived carbon pools. And for estimation of carbon sequestration, we take into account the the recalcitrant carbon, that is fulvic acid, humic acid, and humin. And for estimation of total carbon stock, we take both labile and recalcitrant carbon. These are the process for methods for measurement of soil organic carbon pools. There are different process, that is this is POC indicate the particulate organic matter associated carbon. This is organic matter that is very labile or associated with sand fraction of the carbon. That is dissolved in the water or in the soil solution. And this is water extractable organic carbon, that is also a measurement of labile organic carbon. These are measured by hot water, by extracting through hot water or cold water, or simply normal water extraction. But most frequently the used method is the Wakley-Black method, where the carbon is oxidized through 6, 9, 12 molar H2SO4, and the 4 fractions are determined, that is fraction 1, fraction 2, fraction 3, and fraction 4. These are for organic carbon. Total out of the total soil organic carbon is divided into 4 fractions, that is fraction 1, 2, 3, and 4. And fraction 1 and 2 is taken as labile carbon, and 3 and 4 is taken as recalcitrant carbon. And another method that is being now getting more popularity is acid hydrolysis method, where organic carbon is hydrolyzed through strong acid like H2SO4. And 2 parts is generated. One is acid hydrolyzed, another is acid non-hydrolyzed. Acid hydrolyzable part is referred to as labile pool, and non-hydrolyzable part is referred to as recalcitrant pool. For biochemical estimation, we use generally microbial biomass carbon, and others are there also, like basal soil respiration, mineralization, nitrogen, but most used parameter is microbial biomass carbon to estimate the biochemical uh, pool of soil organic carbon. Now, how soil organic carbon stock is estimated? Formula is simple, that is ABCD, where A is the area in hectare, B is bulk density of the soil, C is carbon concentration in percentage, and D is depth of soil layer. And what you get is carbon megagram per hectare. And for carbon sequestration, we use the similar formula, except the C in place of C, that is CR is used, that is recalcification. So for a total silvopastoral system, total carbon sequester or total carbon stock, we estimate as above ground biomass carbon stock, below ground and soil carbonate stock, and then we sum up this. Some assumption that is taken, but they are erroneous assumption. We should be careful. In the biomass is 50%, but it has been found that often it is less than specifically when we measure on dry weight basis. And all biomass represent sequestered carbon. That is not only long-lived carbon pools are referred to as sequestered carbon. The harvestable part of the carbon, the biomass should not be counted when we are talking. Tree biomass estimates based on existing biomass equation are applicable to agroforestry situation. This is not true, because agroforestry equation has been developed where trees were grown in closely spaced situation. But in case of agroforestry or silvopastoral system, the trees are grown in a dynamics changes. All carbon in soil represent sequestered carbon. That is also not true. Only long-lived carbon, that is the recalcitrant carbon pool, should be taken care for quantifying the carbon sequestration in soil. Carbon sequestration is same as carbon stock. This is not also true. Carbon stock is not a time factor, but carbon sequestration is a time factor. Trees has little to do with root biomass. That is not also true. At every year of as the tree grows, there are different ratios of root to shoot. So using a generalized root to shoot ratio is not good for estimating the actual carbon stock of a tree or grasses. Amount of carbon sequestration is generally uniform for a base. This is not also true. For that, we have to what we should do. We should use the nested plot design in a scattered manner. That is, we should increase the number of nested plot within a silvopastoral system to minimize the error or to minimize the spatial heterogeneity. Now, these are some outcomes which we have we have achieved through in different silvopastoral system and in our research farm. Ficus as well as moras and Madhuka, latifolia, and acacia and acacia nilotica based silvopastoral system. Carbon sequestration at 0 to 30 centimeter soil layer is mostly controlled by biological factors like soil biomass carbon and enzyme activity. However, if we go to the deeper layer, that is the pH, total polyphenol, water soluble carbon, amorphous iron oxides, and silt plus clay play major role. Among them, silt plus clay and total polyphenol content are the major dominant player to enhance soil carbon sequestration in the deeper layer, that is 30 to 60 centimeter. Recently, of the eco restoration efficiency of a particular silvopastoral system by using biological activity index and carbon management index, and for measuring this, you can easily we have developed also our statistical package. You can simply go to the R statistical package and just input your value eco-restoration efficiency of a particular system can be obtained from that R statistical package. We have seen that in a semi-arid condition, the eco-restoration efficiency of acacia-based system was the highest, although the biomass production was significantly higher for ficus-based silvopastoral system. This is because the eco-restoration efficiency index not only take into account the biomass, but also it take into account the biomass plus carbon accumulation proficiency as well as the microbial diversity. So the overall system or ecosystem part is taken care by the eco-restoration efficiency, and because of that, the acacia-based system has outperformed the ficus and moras-based system in terms of total eco-restoration efficiency and also eco-restoration efficiency at both the soil layers. And it is and in Jhansi pastoral system, the highest carbon accumulation and carbon stock was observed with acacia-based silvopastoral system, where the stock was nearly or carbon accumulation was nearly 7 megagram per hectare, but carbon sequestration was only 8 megagram per hectare at 0 to 15 centimeter and 7.4 megagram per hectare at 50. Carbon stock on carbon accumulation sequestration is highly different, and their carbon sequestration is only nearly 50% of the total accumulated carbon. Now as we deduced from our experimental theories that carbon sequestration is the backbone of ecosystem systems, where the degraded land could be restored through the establishment of silvopastoral system. It improves the soil moisture condition, soil structure and porosity, and also the biomass yield, which ultimately lead to the generation of greater economy, and that greater economy also leads a farmer to restore more degraded land through using the silvopastoral system. So we should be more focused on role of microclimate on carbon sequestration in silvopastoral system. These are some future research topic that we should plan in future to critically and more accurately determine the carbon dynamics in a silvopastoral system. They are that microclimate role on carbon sequestration should in silvopastoral system developed. Silvopastoral system offers a positive carbon credit or not. We have to estimate that. And landscape designing and spatio-temporal variations we have to also quantify. And silvopastoral system integrated in societal planning and urban planning to achieve carbon zero or zero carbon society or carbon neutral society. Thank you.
Thank you, Dr. Abhijit, for your very nice talk on quantifying carbon dynamics in silvopastoral systems. The presentation is open for discussion.
Thank you, sir.
If any of the participants,
I am happy to answer.
Yeah. If any queries or clarifications from the participants. Yes, any questions, participants? Dr. Parul, Sharga, if you want to interact with our speaker.